The second goal of section 6.6 is simplifying expressions. When you have an expression with rational exponents, you can use the same rules as any exponent properties out there. For example, when you're talking about multiplying two bases, well, the rule of thumb or the rule of multiplying two bases is you add exponents. So for example, if we had a to the m times a to the n, that's the same as a to the m plus n. Well, that's the same thing here. If I have p to the 1/4 times p to the 9/4, that's the same then as p to the 10/4. But of course that fraction can be simplified, and it should be simplified into 5/2. Now you don't have to write it as a radical. The rule of thumb there is that when you're working with fraction or rational exponents, you can leave the answer in rational exponents. If you're working with radicals, you should put your answer in radical form. Doesn't mean you can't translate from one to the other in between. Okay, so here we didn't have to go to radicals. We just left it as a rational exponent. Here, this one, we have 1 over r to the 4/5, but according to simplification rules, you're not supposed to have a rational exponent or radical in the denominator. So I would need to multiply by something that would give me a whole number exponent in the denominator. So I'm going to multiply by r to the 1/5 because that now would add up to 5/5. So that I would of course have to do both top and bottom. So the simplified form is r to the 1/5 over r to the 1st. And that is simplified because there is no rational or radical in the denominator. All right, the second goal, the next example is the second goal is example 5, and they just talk about a little bit about some of these other properties. Here we have a radical in the denominator. Here we have a radical in the numerator. You cannot divide 32 by 2 because they do not have the same index. They have to have the same index to be able to simplify those. So what we're going to do here, it's going to be easier for us to translate this back to rational exponents, which this, of course, if you look at the 32, that's the same as 2 to the 5th. And so this translates over to 2 to the 5/4. Now 2 here is by itself. So the base is still 2, so it's 2 to the, or the cube root of 2, which is 2 to the 1/3. Okay, now what I have here is I have the same base and rational exponents. So I can use the property that when you have the same base and you're dividing, you can subtract the exponents. So that's 5/4 minus 1/3. Now, of course, you're going to have to get a common denominator here. And this is, of course, 15/12 minus 4/12. So that's 11/12. So my answer is 2 to the 11/12. Okay, here again, you have bases that not necessarily 16 isn't the best base here. 2 to the 4th would be the best base, so we're going to do that. All right, so here you have the cube root of 2 to the 4th, x to the 4th. You could rewrite this, however, let's see, if by simplifying radicals, which we've done in 6.5, we know that this is 2x cubed root of 2x. Now here we have a rational expression in the denominator, and to multiply top and bottom by something to get rid of that rational exponent, we need to multiply by the conjugate, what's going to give us whole number exponents in the denominator. In this case, it's like saying the square root of y, so we're going to say y to the 1/2 plus 2. It's the conjugate here that's going to matter here. So y to the 1/2 plus 2 to the both top and bottom. When I FOIL the denominator, I end up with just y. Of course, the inside outside add up to 0, and then I end up with minus 4. The numerator ends up with y plus 4y to the 1/2 plus 4. And of course, you cannot simplify the y's or the 4's because they are terms and not factors. This is just a list of the simplification rules. They have it in the end of the 6-6 lesson. You might want to look at that and process each one of those. Think about them. What do they mean by those? Simplifying rules, making sure that you have no negative exponents at all throughout the whole expression. You're not supposed to have negative exponents, so you have to process that. Remember, a negative exponent, if you have a negative exponent and it's in the numerator, you have to move it to the denominator. If it's in the denominator, of course, you'd move it up to the numerator. Number 2, no exponents throughout the expression that are not positive integers in the denominator. So we saw that. We saw that we had 1 over r to the 4/5. That was not an integer. It wasn't negative, but it was positive, but it was not an integer. So we had to make it an integer by doing this. Multiplying by r to the 1/5 gives me just r to the 1st. That is the positive integer I was looking for. And of course, the numerator can have rational exponent as long as they're positive. Number 3, not a complex fraction. That means a fraction within a fraction. You are not supposed to have fractions within fractions. That would be like saying 1 over x over 2 over x squared or something like that. You can't have a fraction within a fraction. Number 4, index of any remaining radicals is the least number possible. So for example, if we had the square root of x to the 6th, we should not have that. We should have x to the 3rd. So that remaining radical is the least number, or the index of the remaining radical is the least number possible. Another one would be like this. If you had, let's say you had the 4th root of 4. Well, that is not simplified because even though you can't take the 4th root of 4, what you can do, this is the same as 2 squared. So the 4th root of 2 squared, so 2 to the 2/4 power, or 2 to the 1/2, or the square root of 2. So the 4th root of 4 is the same as the square root of 2. And that's how it should be written because that's the simplest index possible.